Welcome to Lesson 15. Learn C programming on the Raspberry Pi. Okay, we're starting to get someplace with C now, and today I would like to start writing our tic-tac-toe program. It's going to be pretty straightforward, pretty simple. It's at the beginner's level, so no need for anybody to panic. So let's first go over to our Raspberry Pi, and we will bring up our editor. Okay, so the last time we were looking at how to print out a table and how to initialize a table. And I said that what we'd like to do eventually is we'd like to have a tic-tac-toe game working on the Raspberry Pi using 9 LEDs or 9 light emitting diodes. So let's begin with that. First of all, tic-tac-toe, for those of you who don't know, I'm sure you all know, has 9 squares. So it's basically a 3x3 table. But what I'm going to do, for simplicity, we can modify this later, I'm just going to make a table of 9 like this, and I'm just going to initialize them from 0 to 8. Let me just move some of this stuff over here. And we don't need 8. Just going to initialize. So this will be our tic-tac-toe board. In fact, what I'll do is I'll call it TTT. In fact, I'll save this file as save as, and I'll put it into lesson 15, and I'll call it TTT, tic-tac-toe .c. Okay. So when we start with main, we initialize. Now what I'd like to do though is, instead of having this table, this tic-tac-toe table, as integers, I want to have them as characters, and I'll explain that in a minute. So that means that each one of these guys must be a character. This is an important distinction because characters we use single quotes to denote a character. So, and numbers can be characters, or they can be integers or numbers. There you go. So I have a character array of 9, and in the array I just put these 9 characters now. The character 0, the character 1, the character 2, and so on. Okay. And what I like to do then, well, let me just get rid of all this stuff since I'm starting from scratch here. I want to be able to have one integer for the move the person enters. This is going to be a simple game. In other words, all I'm trying to do here is have two people play tic-tac-toe. So one person could be player A, the other person could be player B. Shouldn't be too difficult. And when they enter the move, the move can be from 0 to 8, which would be the square. So let me just initialize the move here. Let's see. Maybe I'll just initialize the move here to 0. Yeah, why not? And then we'll say while we have to wait. We have to have a way to get out of the game. So I'm going to put a while loop in here. I'm going to say while move is less than 8 or less than 9. Sorry, so the move is less than 9. So I'm going to keep doing this loop. I'm going to keep doing this loop while the move is less than 9. So the move could be a 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I will just ask the person here. Well, we're going to have two players as well. Let me just call these players A and B. Character. Player, I'll initialize. We'll have A will be the player that starts. And now I'll say printf enter move for player %C. Okay, so we enter move for player C, player %C, so it could be starts with an A. Player A starts the game. And then of course we have to do a scan. %D, quote, comma, and we have to scan in the move. Like so. Notice that again when we're scanning in, move is an integer up here. So we have to scan in and tell it here's the address of move. So the idea here is player A first puts in his move, and the move could be, let's say, move is 0 to 8. Is anywhere from 0 to 8. Okay. Now while the move is less than 9, if you put in a move of 9 or 10 or 11, that should knock us out of this while loop. Okay. Well, now that we've updated we've got the move from the person, then we have to update our table here, or our array. Don't worry about the array being only one-dimensional. When we print it out, we'll print it out as a two-dimensional. So it'll look more like a tic-tac-toe board. So I just want to say TTT bracket move is going to be equal to, and I'm just going to put in the player. Remember, TTT is an array of characters, and player is a character. So if the person types in, for example, let's say he puts in his move as 0, well, where the character 0 was, there's now going to be the capital letter A. Of course, then I have to switch the player to the next player. If I could put something like this, if player is equal to A, if it's player A, I could say then the player is equal to player B. Else player is equal to A. And this should be the end of our while loop. So if you look at our while loop, it just goes around basically changing the array every time someone types a number in from 0 to 8. Actually, the logic here isn't really as neat as I wanted it to be, but it will work. Now the problem is while we're going in this loop, A is entering, then B is entering, then A is entering, then B is entering, and they're going round and round and round. We also need to print out our tic-tac-toe board. So let's print the tic-tac-toe board right up here. We'll say printf. So at the very start of the game, we'll print the tic-tac-toe board. So we'll print out %C, 2 spaces, %C, 2 spaces, %C, /n, quote, comma, ttt bracket 0, comma, ttt bracket 1, comma, and ttt bracket 2. So you see what I did with that print statement here. I printed out the first row of the board, which is 0, 1, and 2. That's the first row. What I'm going to do now is I'll print out the second row like this. So the second row is going to be TTT at 3, 4, and 5. And then we want to print out the last row like this. 6, 7, oops, 7 and 8. Okay, so let's just review this. Let's just save it first. We start off by initializing the board to these characters. Remember, they're characters, not numbers. They're not integers, in other words. We set our move to 0. We set our player to player A. We say while move is less than 9. Well, move is 0, so it is less than 9. So these 3 lines are executed, and we print out our board. Then we ask the person to enter a move, and he enters a move from 0 to 8. And then we change the tic-tac-toe board. If he entered in 8, for example, then TTT at 8 would be an A. So we change this to the letter A, which means A put his mark there. So this is really not X's and O's, this is A's and B's. We can call this game A's and B's. And then what we do is we switch the player. If player equals A, player equals B. Else player equals A. So we switch the whatever the player was, the player becomes the other player. And then we go back to our loop here. Okay. The problem I see is that if the person ends up typing in 9, TTT at 9, there is no TTT at 9. So this could be problematic. So what I'll do is I'll just put a little if statement here. If bracket move is less than 9. If the move is less than 9, then I'll update the table. The reason I put that in is because the way we're going to get out of this loop is we're going to put in a large number for move. If the person puts in move 200, I don't want to say TTT at 200 equals player, because that could jump outside of my memory and cause a crash. So I'm just going to put a little check in there, just like that. Okay. So let's save this. Let's compile it, see if we can get this thing to do something. There's our program. See if it compiles. Oops. So line 19, I guess, we have an error. Well, we forgot to put a semicolon right after the player equals A. So we'll add that semicolon in here. Save it again. Try it. And now it works. So we're ready to run it. And it says there's our table 0, 1, 2, 3, 4, 5, 6. Well, enter the move for player A. Let's say that A wants to put his mark in the center, so he would type in 4. And you notice now A has his marker in the center, and now enter the move for player B. And let's say B wanted to do 2, for example. B could do a 2. And now we have A in the center here, and we have B over here. So you can see A and B are now playing. And we could go for player A again, could go to, let's say, an 8. And B goes to a 6, for example. And now A could go to a 0, and A has, technically it's won the game because A has 3 A's here, and it's won the game. So we don't have a check for when there's a winner. In fact, we hardly have any checks in this, so it's very susceptible to all kinds of errors. Now we put in a large number like 12, and that exits our game. Okay, so we have some kind of a tic-tac-toe playing game here. It's very trivial, very simple, but it sort of works. And I think our next step will be to somehow implement this into the Raspberry Pi hardware so that we can use light emitting diodes instead of having just numbers here and letters on the board. We'd like to have 9 light emitting diodes, and then each diode can be lit up in the color of the user. So how do we do that? Well, I do have an example here. Let me bring it in. I will open it like this. Open. And I think I just put it in a directory called stuff. And there it is. And let me save this guy. I want to save him now into our Lesson 15 directory. Lessons and Lesson 15. Save. Okay, well, I'm not going to, you notice this, this example here is just using 2 GPIO numbers. And why is that? Well, that's because I'm using a what's called a red-green LED. It's a LED that can display 2 colors, either a red color or a green color. Of course, if it displays both of them on, then you get an orange. Anyway, let me turn on my camera here so you can see what I'm up to. There it is. And I'll just minimize this window. Okay. First, let me show you one of these LEDs. If you look, I see I have a whole bag of these guys that I bought. I think they're about 50 cents each. So let's take one of these LEDs. I'll just show you how they work. Okay, let me move this out of the way here. If you look at this LED, let me put it on the table here. If you notice, this LED has 3 leads. The middle LED is the cathode, so it basically goes to ground. So this is one of these LEDs. So the middle line, which is the black line, goes to ground, which is the ground pin on the Raspberry Pi. And then I have the other 2. The short, all the 3 leads are different lengths. The long one, the middle one, is the cathode, is the ground. The shortest one, which is this one over here, the one on the left, the shortest one is the red LED, and the medium length wire is the green LED. So if I put a voltage from the cathode to the red anode, I would turn on the red LED. See, inside this little glass case, there are 2 LEDs, a red one and a green one. Okay, so and then of course if I put a voltage from the cathode to this other lead, the medium-sized lead, then the green LED will turn on. And of course if I put voltages on both these anodes, then the red light will come on and the green light will come on inside this little glass case, and it will appear as orange. Okay, so here is the, you can see the LED. Well, sorry, there's the three pins there. And notice I also have for each, for the anodes, for the short line and the medium line, I have resistors in there. And those resistors are to limit the current, so I don't burn out the LED, or I don't do any damage to my Raspberry Pi. You notice before, when I only had one LED, I just needed one resistor because it was a single color LED. Okay, so let's get this out of the way here, and we'll see if what this program does. Well, I'm using, for the red lead is connected to GPIO 25, and the green line is connected to pin 24, GPIO 24. So again, I'm going to be using the Wiring Pi library, so I need this header file. I initialize the Wiring Pi library, and I set my 2 output GPIO pins to output. What do I do then? Well, I turn the red LED on high, I turn the green LED off, which is a low. So for then I delay for 3 seconds. So for 3 seconds I got the red light. Or I think I have the green. I think I have them reversed here. Anyway, I have one light is on and the other light is off. Then what I do is I switch them. See, I had high and low. Now I say low and high. So basically I turn the other LED on and I wait for 3 seconds. Then I turn them both on, high and high, and I wait for 3 seconds. So this third one, I should get an orange light. And then of course I turn them both to low, which turns them both off. And that's all this little program does. In fact, I can compile it here. Let me try to build it. And it says finish successfully. If I look here, and now I try to run it by LED, you see the green light comes on for 3 seconds, then the red light for 3 seconds, and then the orange light. I don't know if it can't really see it on there, but let me hold that like this, so maybe you'll be able to see it more clearly. Green, then red, then orange. See, the orange is kind of, both of the lights are on. Okay, so our idea for tic-tac-toe is going to be straightforward. What I'm going to do is I'm going to build a circuit like this with 9 LEDs. Well, if I have 9 LEDs, wow, with 9 LEDs, then I need 18 GPIO pins. See, with one LED, I'm using 2 GPIO pins. With 9 LEDs, I'm going to need 18 GPIO pins. I don't know if I have enough on the Pi, on the Model A. Model A only has 26 altogether. So let me just see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 26 minus 12, wow, is 18, I think. No, 26 minus 12 is 14. So I won't have enough pins to do this tic-tac-toe on a Raspberry Pi Model A. I'll have to probably switch to a Model B Plus, which has more pins. Okay, so let me start working on building that board and switching over to Raspberry Pi B Plus or Model 2, which has more pins. In the meantime, for homework, you can try to hack this tic-tac-toe board, maybe enhance it in some way, and just keep experimenting and see if you can get it to work a little bit better. Okay, so this is a very quick introduction to the beginning of our tic-tac-toe, and I will see you probably in a couple days when I get time for lesson number 16. Thanks for watching.